And that's why I told you, even though you are a group, not everybody will get the same grade. That's the first thing I said, right? But also, some people are getting free rides. And the intention of making teams with people that have very high grades and people that have very low grades is not to make the people with low grades get a free ride. The intention is that they learn from the ones that have top grades, and so that everybody can learn better. So, if by any reason you detect that somebody is trying to get a free ride, okay, you let me know at least at the beginning of the last class before the presentation, okay? And I'll put that person aside from your team to make the work on his or her own. If during the presentation, one of your team members, I detect that person got a free ride, you will get also penalized for that. So you have to let me know if you see that somebody is not working at all in your team and does not want to work. Because one thing is not working and another thing is not wanting to work, right? Some people just go there or don't even go to the meetings and just appear the day of the presentation, right? That's what we want to avoid. Okay, guys? To be responsible. So, going into the code now. So we saw how we can print notes, how we can connect them, remember? And we saw how we could print them all once they are connected. Remember, guys? Okay. Today we're going to learn how to deal with a linked list. What is a linked list? And how, just by having the information of one element, we can get everything.
Did you write down everything?
Okay, guys.
I might have.
Remember we played with a note like that? And we said,
Do you
for
mind if I
example,
take a picture of that now?
and like that? So this portion was the data portion. This portion was the next, remember? Right? Now, remember that last class we started playing with them and we connected them and we tried to connect them like one after the other, right? And we call this like M2, this was M, and this was like M3 or whatever. Remember? You remember this, right? Okay. If you remember this, now, you remember that when I wanted to print all the elements, I could do just by printing M2 that get data, and then print M that get data, and then M3 that get data, right? Do it, huh? Yes, hold on 1 second. But then we said that since all of them are connected, if I have access to the first guy, right, I could move and obtain the rest, right? And the problem was that if I moved M2 all the time, I was going to lose M2, because M2 was going to end up being null. Therefore, we created a temp, and made temp initially equal to M2, to the first element, right? Now with this temp, we could move it, we lost temp, doesn't matter, because we can always get a temp to be at the beginning again by putting again to M2, right? Correct? Now, if you realize, what I have built there with the nodes is some sort of linked list. What is a linked list? A linked list is a list where all nodes are connected in this fashion, okay, one after the other, because you could also connect nodes like this, right? Or make nodes connect crazily like that, right? And this node connecting here, and this node connecting here, or connecting here. You could have stuff like that too, right? Correct?
So they can only have a successor. They can't go back.
They cannot go back. In linked lists, all of them are pointing one to the next. Okay? So when you have a list that looks like this, this is considered a linked list. And you're having only one link. I only know about who's next, who's to my right. I don't know anything else. Okay? So that kind of linked list where you just know who's to your right is called singly linked list. Okay? Because you just know who's to your right. You don't know who's to your left. Okay? Got it? Yes? Okay. With this type of linked list that we were playing last time, what information do we need to access all of the elements? Do we need all of the nodes? Which of these access to the first node, right? With having access to the first node, we can have access to everybody. Correct? That first node is going to be called head. It's going to be called the head of the node. Okay? The last node sometimes receives the name of a tail, the tail of the list. We don't need to worry about that now. So we just care about the head, okay? The head of the list is a node that appears at the beginning of the linked list. And from that node, we should be able to traverse the whole linked list. So now we start comparing this against arrays, for example. With arrays, you define a fixed size, and if you just use 2 elements, and the array was size 1000, you're wasting 998 spots, right? Correct? Here, with linked list, if I have a linked list like that and somebody tells me, oh, add this new element, all I have to do is just add one node at the end, for example. Right? So I can only have as many nodes as I need. I don't need to have more nodes that I don't need. Make sense? So this is more efficient memory-wise, right? Correct? But what's the problem? If somebody tells me, what's the content of your fourth element? I have to start from the beginning and go one by one, sequential access. Right? Because I only have the head all the time. Correct? If somebody tells me, give me the element on the fourth position, I have access to the head, and from there I have to move 4 spots, right? Correct? Do you understand what I'm saying?
Yeah.
Remember, when somebody gives you a linked list, all they give you is just the head, access to the head. And from there you have to access all elements. Well, doesn't seem to be clicking.
No, I understand. It's just I see a downfall.
It's a downfall.
Yeah,
It's a downfall.
that's what I was going to
Yeah,
say.
it's a downfall. It's a disadvantage.
You have to start from the beginning if you want to get to the middle. And I had
Correct. So
every
you have
time.
to move sequentially.
That's why I was looking at that way.
Yeah, what I mentioned first was an advantage, which is that this is dynamic memory as needed only. You're not wasting memory. That was an advantage. But what I just mentioned is a disadvantage, a downfall, like you were saying. For me to access this guy, I have to move from here all the way. With arrays, you have an advantage, because with arrays you have random access. With the index, you move directly there. Got it? Yes? So those are the pros and cons. Yes, Arlene?
If you start with the head and you want to add one, is the one you add to the left or then put to the right?
If I start with,
If you just start with the head, you don't have the others yet and you want to add one, is it then placed to the left or to the right of the head?
good question. Arlene is asking. If I have this node only, imagine just a head. Obviously no, right?
Last week it was to the left, but now I see they're to the right.
Just wait and see. And somebody tells me, I want to add this node, this red node. Shall I put it like that, connect it here, or shall I connect this guy here? You understand what I'm saying?
Right.
Okay, you can do any of those, whatever you prefer. So you can say,
You have to
add,
right?
we're going to create methods to add a node to a linked list, and we're going to create 2 methods, one called add first or add head, and what it will do is any node you add will be the new head, will be the first one. You will be putting the red here, for example, right?
So it pushes everybody forward.
Correct.
Will the data also get pushed back?
You don't need to push, you just connect it to the head, that's it. Because everything is connected already. You just connect it. Got it? It's like these 4 guys are my linked list. Say, Yuken is the head. If I want to do add first, maybe I want to add Alberto. Add first, all I have to do is put Alberto here and point to Yuken. That's it.
Yeah, but if Yuken has a number and you add Alberto to it, does Yuken still keep that number?
Yeah. He's the old head. He's the new head now.
Okay.
Got it? If I want to add last, which is the other way of working, I will put Alberto here, right next to. Yes.
This is because they don't have indexes, right?
Sorry?
This is because they don't have indexes, so
Correct. They don't have index.
that's why he was thinking. Yeah.
All of it is, imagine like they are all, say Yuken is putting his arm on top of Darlene's shoulder. That's how they are connecting. And Darlene on Sadie's and Sadie's somewhere, right? Then I put Alberto at the beginning. I have to make Alberto's arm on top of Yuken. If I want him to be ahead, so at first. If I want to do an at last, I will have to put Alberto here and make him put his arm over Alberto's shoulder. And then he will be the last. So we're going to have 2 ways of working. That's your question, Alice. So we can choose whichever way we want to work. But in all cases, what we need to know is only the head of the element, or the head of the linked list. Right? Yes.
Can you break the link and add somebody in the middle, or no? They got to be the
We
front?
can do that too. And we're going to see how that's done. That's more complicated. That's called add in the middle, or maybe you want to keep the list sorted, right? And you want to add an element that cannot go on the last because you're going to break the order, right? So we're going to see all of that.
But when you're adding something at the end, since you only have the head, do you have to, don't you just kind of like, you push everybody
You
back?
don't need to push anything.
I mean, like the references, everything, don't you just,
You're going to see that soon. Don't worry about it. Okay? You're going to see that soon. I'm going to make it easy. Okay. I'm going to create my class linked list. This is a name. Let me create a class linked list here. New Java link. This should be the name. Change it, right? Okay, I'm gonna call this a linked list class. Now, for the linked list class, I need access to the head. I need to have the head, right? That's all the information I need. But what's the head? It's a node, right? So I need to define my class node here. What I will do is just copy paste the class node that I had before in here, because the node's going to be exactly like that I had before. Got it? I'm going to reuse this guy. Copy, paste. Okay. My class node. I'm going to play with a linked list of integers still, okay? But again, for your project, you wouldn't have int data here. You would have to create another class, say coordinate, and use an object coordinate instead of data, right? Instead of int for your data, right? Okay, so let's continue playing here. You have my node. What other thing do you think is important in a linked list?
The guy at the end.
Well, when you have an array, what do you need? What do you think is useful in an array to know?
Value.
Value.
How big it's gonna be?
Range, kind of. Sorry?
How big it's gonna be?
The size, right? The size of the array, right? Now, in a linked list, do we need to keep track of the size? The answer is really no, because at any point when you have your linked list, you can traverse it and start counting, right? And you know how many you have, right? That could be a little costly. Every time you want to know the size, go and traverse the whole linked list. It's kind of a lot of work. So just to save us work, I'm going to have an attribute size, and as I add or remove nodes, I will increment it or decrement it. So that if somebody asks me what's the size, I can just call get size and get it.
But you have to do the manual if you want to increase or decrease.
Correct. I'll have to do that code manually.
So it's not, okay.
But it's optimal because I don't have to traverse the whole linked list to determine the size every time I need it.
Just
Got it?
one variable.
Just one variable that will keep track of that.
That's when you know the size that you want.
Correct. So I will say here int size, right? I'll create my constructor linked list. I have two ways of creating my constructor linked list. I can create my linked list by providing the head. What's the head of the linked list? Okay, that's one way, right? I create my linked list and I already tell him, okay, look, this node is the head, right? So for that, I'll need to provide a node to specify as my head, right? Correct?
Yeah.
And size would be what? 1, because at least I have one node now. That's the head, right? Got it? Remember when you say array list, say A equal new array list, you can do that, right? Right, guys?
Right.
What happens there? Do you have any element in your array list? So we have to provide also a way of creating a linked list, an empty linked list. How do we create an empty linked list? We don't specify anything for the head, so my head should be no, right? Because the linked list doesn't have anything, right? It's an empty linked list, right? And the size should be 0. Got it? Clear? Now let's start playing with it. I'm going to start playing with the methods. Okay, I'm going to say at first we'll simply add a node n into the linked list. Let's see how we do that.
Professor,
Yes.
don't you need to make a parameter in public linked list for the size?
No, because the size, the first time is 1 if you are adding, if you're telling me who the head is going to be because you're going to have a head, right? If you tell me that, if you want to create a linked list and you tell me, okay, this is the head for the linked list, then at least I have one element, size 1, right? Because I'm going to have a head.
Okay.
But if you don't tell me anything, you want the linked list to be empty, my size is going to be 0. Right? Don't get used to the recipe of having the constructor with the parameters as matched as your number of patches. Doesn't work like that. It doesn't analyze what you need. In this case, you will need to pass a size, right? You can determine the size right there. Okay, so let's play on how we add first. This is what I mean when I say at first. Imagine this is my linked list. Okay? So which one will be my head? This guy, right? Correct? Now I want to do at first. So if I have a node, say n, this is my node n, the one I want to add. Okay? This node is initially pointing to no. It's an empty node. Right? It has a data, maybe 7. Let me put numbers here, just to put something. Can be 7, can be the same, doesn't really matter. Or 17 if you want, so doesn't really matter. Now, if they tell me, add this node to the linked list, I want to connect this node to the linked list and make it part of the whole linked list. Correct? So far so good? Now, if they tell me add first, what does that mean? Darren, it looks like you cannot see that. Can you see? What did you see here, man?
I'm trying to just.
I don't know how you can understand like that, man. But anyway, if somebody tells me add first this node, that means that I should connect this node here, right? I want a node to go at the beginning, right? So this method, add first, should take any node n and put it at the beginning of the list. That's its job, right? Now, if that happens, if this node is going to go at the beginning of the list, now I should update. This should no longer be my head. This should be my head. Right? Got it? Yes.
So you're creating a battleship game and you're putting the coordinates. How you're doing is as you're adding, you're just pushing the data like that with the list.
It depends on which one you want to use. In that case, it would be at last. Each coordinate you should add it to the end, not at the beginning. Okay. Now, let's analyze again what we just did. Okay? You understand what I just did, right? This is head. And this guy is n. Now, what do I need to do? I need to connect n to here. How can I connect that?
Create a node and make the next.
I have the node already, n.
Make
So
any
make
relation.
his next equals to the head. Set. There you
To what?
go. To the head.
Is that clear for everybody? To the head of the list, right? If I do that, I'm breaking this node and I'm making this connection. What do I need to do now?
Then you need to read just what the head is
How do I do that, Clayton?
by saying head equals n.
Excellent. Now my head is equal to n. So, this guy. And I'm done. How hard is that? How hard is that, guys? Too hard? Too complicated? Yes.
You have to set the head with the
Yes, because otherwise,
doesn't automatically just know that this is what you're doing.
if you were using the Java library and you would say import Java utility linked list, yeah, everything would be done for you. But I'm teaching you how to create a linked list and how to do everything from scratch. Okay, so you have to do everything manually. Got it?
Okay.
Yes.
What happens to like the 10 inside the previous head? What happens to that number?
It's still there.
It's still there?
It's still there. Remember, all of this, all the thing in black here remains exactly like that. This does not change. There is no reason why this should change. All I'm doing is just connecting one guy there. Why should that change? Got it?
I think.
If I can bring in Alberto and putting him in front of Eugen, they can continue sitting there. I'm not moving them. Got it?
Yeah, I get the order. Very-
You get the logic, right?
Yeah.
So I should do n, that's set next, to the head, and now the head should be updated to be n. Now, every time you play with linked lists, you have to be careful and see if this works for all cases. For this linked list that I draw here, that I just drew here, that had 3 elements, worked fine, right? What if the linked list were empty?
You have to check for no.
What would be the head? If I do this, what would be head if the linked list were empty?
No. So you have to say
Put
no,
here,
no.
if empty, right? The head would be null, right? So what would happen if I do this line in blue? I would say n, that's set next, no. So here is n, with 7 and pointing to no, right? I'm saying n set next to no. I'm doing nothing. It's putting it again to no, it's already no. right? Correct? And then I'm saying head equal n. This should be the head. Is that correct? Yeah, if the linked list is empty and I'm adding the first node, that node should be the head now. Isn't that clear? Yes? Yes? So this logic works perfectly, right? These two lines are fine. Good?